Okay, YouTube, in this video we're going to take a look at a quick warm-up here where we're going to write the rule for an expression here, or at least a sequence of values here, write a rule that would define that sequence there. So I guess we could start with number one here. It says for the nth term of this here, I think that it's a good idea to write this in kind of a domain and range, input-output sort of situation. So we say our domain is always a set of natural numbers with the sequence. So our first term is 2, our second term here, that's equal to -4. Third term is equal to 6. Our fourth term is equal to -8. And our fifth term is equal to 10. So what we're trying to do is find a relationship between the value of our input, which is our n value, and our output here, which would be some a sub n in terms of like a sequence here. So what is it that we're doing to our n values to get these a sub n values here? Well, I noticed that it's alternating its sign every time. And I know that in our last set of videos here we said that's really indicative of a term or at least a factor on the rule here of -1 to the n, because every time n is even we'll have a positive output, every time n is odd we'll have a negative output. But also that these numbers are going up by 2 every time. So I kind of spot that this is a linear pattern. So I could kind of say that 2 times n would be what's going on here. Now I'm going to test this out and see if 2 times n would actually give me what I need here. But 2 times my 1 here would give me a 2. 2 times my 2 would give me a 4. 2 times my 3 would give me a 6. And so on and so forth. So in terms of an overall rule here, we would say that a sub n, or the rule, would be 2 times n times -1 to the n. And before you accept a rule, you always test it. So I'm going to check to see that this works here. If I were to plug in our first term here, I get 2 times 1 times -1 to the 1, which ends up being 2 times -1, which is -2. And my first term was a +2. So remember, if you end up having alternating signs here and -1 to the n doesn't work, what we do is we just put plus 1 on top of it, and this would work for you now, changing all the negatives to the next term over. So now looking at number 2 here, we say write an expression for the nth term of this. I noticed that there are a lot of fractions here, and so when we have fractions, I'm going to put this 1 over 1 here. 1 over 1, I've got 1 over 2, I've got 1 over 6, 1 over 24, 1 over 120. We say, what's the pattern here? And so on the top, what I notice is that my rule is always going to have a 1 on top. So if we write this rule as, say, b sub n, I would say that the top of my expression always has a 1. Now for the bottom, what are we getting here? 1, 2, 6, 24, and 120. And what I want to do is refresh your memory about factorial. So we say 1 factorial is 1. 2 factorial, which is really 2 times 1, is 2. If we get 3 factorial here, we get 3 times 2 times 1, which would be 3 times this last 2, which is 6. And these are where we're digging out our numbers here. This is 4 factorial. 4 factorial would be 4 times 3 factorial, which 3 factorial is 6. So 4 times 6 is 24. So basically these are factorial values on the bottom. So we'd say that our rule on the bottom is just whatever the term number is, we'll take the factorial of that, and that'll be the bottom expression here. So now for this last one, I want to simplify this, rational expression, but that has factorials. So we have factorials here. Remembering that when you write a factorial, it's really that thing times every integer below it all the way down to 1. So for instance, if I were to write this out, this would be n plus 2 times 1 less than that, n plus 1, times 1 less than that, n, times 1 less than that, n minus 1. And you can see how this is just going to carry on all the way down to 1. Now on the bottom we have n factorial, but see, n factorial here is n times 1 less than that, times 1 less than that, times all the way down to 1. But you can see how n times everything below n here is going to cancel out with n times everything below n on the top. And what we're left with is just this expression n plus 2, n plus 1. So that would be the simplified form of this expression right here. Cheers.